Investigation of Curves, Section 1, Equations and Properties of Curves. Video 7, Converting between Polar and Cartesian. As we discussed in the previous two videos, sometimes it's more useful to have a curve in one format for one purpose and a different format for another purpose. So it's important to be able to convert between all three forms that we've been using. The previous videos looked at converting between parametric and Cartesian and converting between parametric and polar. This time we're looking at converting between polar and Cartesian. It's useful to remember the following for converting between polar and Cartesian. First of all, r squared equals x squared plus y squared. Tan theta is y over x is r cos theta, and y is r sin theta. Let's have a look at an example of expressing a polar equation in Cartesian form. So we've got r equals cos theta plus 2 sin theta. Well, if we multiply through by r, then we get r squared equals r cos theta plus 2r sin theta. And then this is giving us something where we can do some substitutions. We know that r squared is x squared plus y squared. We know that r cos theta is just x. We know that r sin theta is y. So we've got x squared plus y squared equals x plus 2y, like that. So here's that written out for you. Our first step was to multiply through by r. So we've spotted that if I have r squared here, I can rewrite that. And if I have r cos theta and r sin theta, I can write those in terms of x and y. Then that gives me r squared equals x squared plus y squared, x equals r cos theta, y equals r sin theta, giving me this final equation of x squared plus y squared equals x plus 2y. What about going back the other way then? We've got something in Cartesian coordinates and we want to write it in polars. Well, a question might look like this. Show that x squared plus xy plus y squared equals 1 can be written r squared equals 1 over 1 plus sin theta cos theta. Well, the first thing that I'm noticing here is that I've got an x squared plus y squared hidden in here. So I want to rewrite that x squared plus y squared as r squared. So I've got r squared plus xy equals 1. And then I can replace my x and my y with r cos theta and r sin theta. So I've got r squared plus r cos theta times r sin theta equals 1. R squared plus r squared cos theta sin theta equals 1. Taking out a factor of r squared, 1 plus cos theta sin theta equals 1. So finally, r squared equals 1 over 1 plus sin theta cos theta as required. Let's look at that written out step by step. So starting off by spotting that I've got my x squared plus y squared, which can be written as r squared, rewriting my x as r cos theta and my y as r sin theta, multiplying this out and taking out a factor of r squared, and finally rearranging it. Now there's a temptation here to write this as r equals and then putting a square root around everything. The problem with this is if you start plotting these things, the square root is just giving you the positive square root, so you're going to miss a branch of your graph. So what you should be doing instead is using plus or minus and plotting plus the square root and minus the square root in order to get your full curve. But this is why it's useful to be able to translate between the different forms, because sometimes you can plot it one way much more easily than you can plot it another. In this video, you've learned how to convert between Cartesian and polar forms.